All right, let's do day 18. These have been getting more painful and less fun the last few days, and so I fully expect that day 18 will continue that trend, but uh, I haven't been defeated yet. I've been close, but not totally. So us uh, let us see. 18. Pulling boulders. You and the aliens finally reach fresh air. You emerge at the base of a large volcano. Fortunately, the lava seems to be flowing away from you towards the ocean, but the lava is still being injected, so you're sheltering the exit outside. See the lava landing in a pond. Hear it hissing as it solidifies. Depending on the specific compounds, it might be forming obsidian. The cooling rate should be based on the surface area of the lava droplets. So you take a quick scan of a droplet as it flies past you. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low. As a result, it approximates the shape of its lava droplet with 1 by 1 cubes on a 3D grid, each given its XYZ position. To approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube. If your scan were only two adjacent cubes like 1, 1, 1, and 2, 1, 1, each cube would have a single side covered and 5 sides exposed, a total surface area of 10 sides. Here's a larger example. 1, 2, 2. In the above example, after counting up all the sides that aren't connected to another cube, the total surface area is 64. What is the surface area of your scanned lava droplets? Okay, so let's see. This is long. Okay, so here is here's my first thought. Everything has each cube has a single side covered and 5 sides. Each cube has each one has 6 sides, right? But every time there's a neighbor, every time 2 things are adjacent, you take off 2 sides. And so the question is, how do I quickly find which ones are adjacent? And so let's do it brute force and then optimize. Because brute force will probably be okay for part 1. And now let's say point equals tuple int. And sure, why not? Return sure, I don't like using map, but I'll do it that way anyway. That's fine. And so let's say points equals parse raw. Actually, let me do a set of points. That'll be easier. And what I want to do is do I want a data structure that has all this in? Maybe I do, actually. Class points, which inherits from list of point. I think I can do this. And static method and I'm going to say points as a set of points, okay? And I'm going to say return points of that, okay? So I think that'll work. And let's say points equals points dot parse raw. So let's try that and see if it actually works. Day18.py. Okay, that seems good. And surface area self. Let me do a helper function. Self is area self point, which is a point, and goes to int xyz equals point, return so neighbors equals sure, why not, point, which is going to be an iterable of points, iterator, I mean. XYZ equals points. Yield. Yep. Okay, good. Okay, so return some neighbor not in self for neighbor and neighbor's point. So I think that's right. And def surface area self goes to int, return sum of self destination. Okay, so I think that's right too. So let's run that. $64. And what did they say? The total surface is 64. Okay. So let's try it on this big one. Assert that points dot surface area equals 64 with open day 18 dot text as f, raw equals f dot read, points equals points, no, points dot parse raw, print points dot surface area. Okay, so let's run this. 3412. That's the right answer. Okay, something seems off. Depends on exterior surface area, but your calculation also includes the surface area of air pockets trapped in the lava droplet. Instead, consider only cube sides that can be reached by the water and steam as the lava droplet tumbles into the pond. The steam will expand to reach as much as possible, including displacing any area on the outside of the lava droplet, but never expanding diagonally. In the larger example above, exactly 1 cube of air is trapped within the lava droplet. So the exterior surface of the lava droplet is 58. Okay, I don't quite understand this, but let me think. Cooling rate depends on exterior, but also include the surface area of air pockets trapped in the lava droplet. Instead, consider only cube sides that could be reached by the water and steam as the lava droplet tumbles into the pond. The steam will expand to reach as much as possible. Exactly 1 cube of air is trapped within the lava droplet. So the exterior surface area of the lava droplet is 58. What is the exterior surface area? Okay, so what I want to do is I want to do a couple things. Def is interior, okay, and a point is no. Interior if it cannot escape, okay, and so what I'm going to do is the following. I want to Okay, so I'm going to change what I did because it's not going to scale well. So I'm going to and make sure that let me just raise not implemented. Okay, so what I want to do is droplets. Okay, so class droplets from data classes, import data class. So there's an extra S there. Okay, so class droplet has points, which is a set of points. Okay. Raw to and okay, droplets, that's fine. Some neighbor not in self dot points for point in self dot points. And now let's change this to droplet equals droplet dot parse raw, and you'll see in a second why I want to do it this way. I think I have a good reason. Droplets. And now let's say droplet equals droplet dot parse raw and print droplet dot surface area. So let's run this again, and it still works. Okay, good. So now what I want to do is I want to do the following. Xlow int equals 0, x high int equals 0, y low int equals 0, y high int equals 0, z low, z high int equals 0. Okay, so and then def post in itself. That's what I want to do. Okay, so now what I'm going to do is for is interior is I'm going to do breadth first search and see if I can escape from that bounding box, right? That's the easiest way to do it. A point is interior if it cannot escape the bounding or bounding box. Okay, and so what I want to do is I want to say Q equals dec of points. And scene equals set while Q let me change it this way, set or so I think that's what I want to do. Let's see. While I have a Q, x, y, z, so pull off the next point. If x has gone outside the bounding box, it's not true. Not true. Q, and then for neighbor in neighbors, x, y, z. And now, and yeah, so I need to say and neighbors non-self dot points, right? So I can't go through other points. And I think it said I can't go diagonally, right? Displacing any error Cube size reached by the water and steam. Yeah. I never said that. Okay. Q dot append neighbor. Okay, and then I want to return true. And then def interior points self set dot points. Let's say candidates equals neighbors p for p and self dot points minus self dot points. So anything that's a neighbor and is not one of my points. Okay. Return p for p and candidates. Operator neighbors p for n for p and self dot points for n in neighbors p. So any neighbor, I want to check if it's interior. And I feel like this is going to be too inefficient, but we'll try it, and we'll optimize it if need be. And so now exterior surface area, def exterior surface area self goes to int, and let's say interior points equals self dot interior points, and let's say filled in equals that, but it's actually going to be a droplet with self points and the interior points, and now return filled in surface area. Okay, so let's run this. I'm worried it's going to be too slow for part 2, but we'll see. So droplet dot exterior surface area is 58, so that's right. And let's see if this works or if it's too slow. 2692. That's not the right answer. The answer is too high. Okay. So I did something wrong. And it's going to be very difficult to debug what it was. So print droplet dot exterior surface area. So let's think about what I did wrong. What I did wrong is let me go back. So let me change this. Let's say find interior points, and this is going to be a set of points. And now, because there could be ones that don't, I didn't check enough, basically. So return sets. So we need to find more interior points than this. And then otherwise, we're going to return seen, which is everything we've seen. They're all interior points, right? Interior points set candidates. And now these are not, like, I didn't have enough candidates basically. So what I need is starting points and return P for P in, or let's say IP for IP in IP for P in starting points for IP in self-defined interior points B. Okay, so now this should give me all interior points. And let's try this one more time. 2018. And did I have my unit test here? Let's do assert the droplet dot exterior surface area equals, and would we say that was 58? Okay, let's run this one more time. 2018. That is the right answer. Okay, so what we did wrong the first time was basically I only checked things that were adjacent to lava and then said, is that an interior point, right? The problem is let's say I have like a big circle, right? Then there's a lot of interior points there, and the ones that are not next to lava, I would not have ever considered. So what I had to do is I had to change it and say not start with a point telling it's an interior point, but start with a point and find me all interior points that are kind of connected to it, right? And so that was changing this. And so now what I do is I say everywhere I'd want to start considering, or every pocket inside is going to touch the lava somewhere, right? So if I start with every neighbor of lava and then find what is that interior component, then I'm going to find them all that way. And so the key ideas here were, one, this idea of using breadth first search. I guess you could use depth first search too, it wouldn't have mattered. And saying, starting at a point, can I get outside the bounding box, right? And so that's how we determine interior points. And then two, this idea of, okay, now in order to find these insides, start with neighbors to lava, and basically find the component. And if that component, goes outside the bounding box, we've escaped. And if it doesn't, then we haven't escaped and it's interior. And so then that all works. And so today actually wasn't that bad, which I am glad about. And yeah, perfect. So hey, now I'm all caught up. So perfect. All right, see you next